So did you try U-Substitution on 30 kids?
Yeah.
You did? Did it work?
No.
No, it didn't work?
Yeah, I got you the
Okay, so let's try it out. So you said you want U to be what?
uh,
ln x. So what does du equal?
1 over
1 over x dx. So what does dx equal? X du. Now you substitute this in, you get cosine of what? U over x, and what's dx equal? What cancels? Oh. So what do you get? Cosine u du. What's the antiderivative of that? Sine u plus c. So what's that going to be? Sine of what? ln x plus c. There you go. Good job. Yeah.
We do
The general antiderivative first. Let's use u substitution. What does u equal? 3 pi t. So what's du going to be? 3 pi dt. So what does dt equal? Du over 3 pi. So what does this equal? The integral of sine of u, correct? Du over what? 3 pi. Are we in? We're not in t anymore. What are we using? We're using u. What does u equal? 3 pi t. So what do the limits of integration become? What happens when you plug 0 into 3 pi t? 0. And what happens when you plug 1 in? So you go from 0 to 3 pi now, and you won't have to go back. I mentioned this yesterday, so watch what happens. So what do we have here? We have 1 over 3 pi times the integral from 0 to 3 pi of what? Sine of u du. What is the integral of sine? 1 over 3 pi times negative what? Cosine u, but what are we evaluating it from? 0 to what? To 3 pi. Because we changed the limits of integration, do we have to resubstitute in for u? No, because we already evaluated that part. This is one neat thing. Do you see that negative cosine in there? I don't really like that negative, so where can I pull that negative out to? You can just pull it out. That is totally legal. So you have negative 1 over 3 pi cosine of u from 0 to 3 pi. What's that going to be equal to? Cosine of 3 pi minus what? Cosine of 0. What is cosine of 3 pi? 1, 2, 3. Is what? You sure? Negative 1. And what's cosine of 0? 1. So what does this equal? 2 over 3 pi. There's your answer right there. Right. You end up with an issue, right?
Yeah.
So what did you try for u?
X squared and X squared.
That's a great pick. So du is equal to 2x dx. So what does dx equal? Du over what? 2x. So what do you end up with? The integral of x over u times what? Is that a good sign that you're able to do this? Yeah, you cancel that. That's great. You're still with one variable, right? But what does u equal? Oh, sorry, I just deleted that. I'm not sure how. Over what? 2x? Over 4? Minus 4. So what do the limits become? When you plug 1 into that, what do you get? What do you get? Negative 3. Because when you plug 1 into that, you get negative 3. And now when you plug 10 in, what do you get? 96. So you have this right here. You have the integral from negative 3 to 96 of u to the negative 1 du. Do you know what the antiderivative of u to the negative 1 is? Yes, you do! The derivative of what is 1 over u? ln of u, right? You have this. You're evaluating from negative 3 to what? So far, so good. Still have a major problem. So what does this equal? ln of 96 minus ln of... I will tell you right now that all of the algebra we have done so far, technically the algebra has been correct. All of the steps we have taken have been correct. What's the problem with this? You can't take the natural log of negative 3. So what do you think the answer to this question is? Does not exist. And can anybody tell me why? You're trying to find the area under the curve of that function. Right?
Is it not a function?
Oh, it's a function.
Because the function is the area under the curve from those intervals does not exist.
Why, though?
Because the function...
What? There's something specific about what this looks like. That's a problem.
They're asymptotes.
What kind of asymptotes?
Vertical.
Vertical asymptotes. Is this continuous from 1 to 10?
No.
No. It's continuous on its domain, but its domain does not include the number 2.
Right.
You can't plug 2 in, right? This thing has an infinite spike around 2. What happens if you tried to add up the area under that? Problems happen. And guess what? Did a problem happen?
Yeah.
It really happened. It really, really, really happened. So this one does not exist. Why? It doesn't exist because x over x squared minus 4 is not continuous from what to what? Continuous from where to where? From what to what? What are we evaluating the integral from? From 1 to 10. That's why. Because that function is not continuous from 1 to 10, you can't integrate it from 1 to 10. It must be continuous for this to work. Fundamental theorem of calculus only applies to continuous functions that are continuous across where you're integrating. That was in the fundamental theorem of calculus. It doesn't come up too often, but if you run into this kind of error, you should ask yourself, ooh, there's probably a vertical asymptote or a problem with the function. Okay, so what U-substitution do you... Which one do you think is the most obvious? Whether or not it's right or not. Which one do you think you should try first? Who did root x? Let's try root x. Let's try it and see what happens, okay? I'm curious. Let's see what happens. What does du equal? Oh, come on. 1/2 x to the dx. So you know that 2 du is equal to x to the negative 1/2 dx. So what does dx equal? 2 du over what? X to the negative 1/2. What does that simplify to? 2 du times x to the 1/2. Is my algebra okay?
Yes.
I'm just simplifying it. Is that okay? Can I now throw this up here? Yep, so it's e to the what power? To the u over u times what? 2 du x to the... You can factor out the 2. You have a 2 of e to the u over u. But then what do you have here? X to the 1/2 du. Is there a problem there?
No,
Wait! Do not go too far into the future. I'm asking you right there. Why can't we just integrate that right there? Wait, ready? Time out. Shh. Not asking you what you can do to this. I'm just asking you, why can't I just integrate that right now off the top of my head? Thank you. Now, is there something we could do? Is there something we could do? Does anybody notice something that's right there in front of us? What's the problem? There are 2 variables. We want there to be 1 variable. Is there any way for us to make this have 1 variable?
You made the problem in the first place by converting that to u. Why did you make the bottom one u?
Yeah, you have to.
You don't have to.
Yeah, you don't have to.
Substitute
It's
it
a
for u.
You're all saying wonderful things. What does u equal? You're absolutely right. One way to think about it is you don't have to substitute, but the better way to think about it is you see all this information over here? All of that information, Erica, all of that information is still true. You can use any of this information you want to substitute in here, anything you want. One way to think about it is substituting back in. Another way, Carter, is not to substitute. You're absolutely right. But the point is, when you make a substitution, I want you to substitute everything. And then if you need to resubstitute back, that's fine. So what can you resubstitute back in? Oh, look what happens. Now, is that really, really helpful? Just doing it right there, right? What happens? You get 2 e to the u over root x, x to the 1/2 du. What cancels? Those are gone. So what do you end up with? What do you end up with? 2 times e to the u du, which is just 2 e to the u plus c. That's all it is. This problem was specific. I put this problem specifically there so that you would see or try to see a substitution from what you had before. That's the whole point.
So you can only substitute the variable in one place?
You can, sorry, say that again?
You can only substitute the variable into one of the spots.
You're allowed to do that. Absolutely. Well, they're equal. They are equal, right? U is equal to the square root of x. Sure, you can. Absolutely. Now, hold on a sec. Let's just check one more thing. You guys, some of you, let's start again. We have e to the root x over what? Root x dx. Some of you maybe picked u equals what? E to the root x. If you picked that, what is du equal to? E to the root x times 1/2 x to the negative 1/2 dx. Is that correct? Nice. So 2 du is equal to e to the root x times x to this dx, right? So what is dx going to be? 2 du x to the negative, no, it's not negative anymore if it stays up there, to the 1/2 over what? E to the root x. So where do you plug that in? Watch what happens. What does it become? U over what? The square root of x times 2 du x to the 1/2 over what? What cancels? Now, are we kind of left with a similar position? You have u over what? E to the root x. But what does u equal? And this is du, right? Is that correct? What is e to the x equal to? It equals u. So what do you end up with? 2 times u over u du. What is u over u? 1 du. If you integrate that, what do you get? 2 times... No, you're 2 times u plus c. But what does u equal? What did you say? U? In this case, what does u equal to? So what do you end up with? What did u equal here? What did u equal there? So what does that equal here? 2e to the root x plus, is it the same thing? This was to introduce the idea of substituting back in. This was to introduce the idea of substitute. Do you get the same thing? Yeah, you do. So we have
What was the answer?
58 billion flying pigs. We'll get to there. Y equals negative x squared plus x plus 6, and y equals what? 4. So what does this vaguely look like? What's the best way to, if you had to do this by hand, how do you graph that? Oh yeah, or you could just make it negative of x squared minus x minus 6. What does that factor into? X minus 3 times x minus plus 2. So it crosses at negative 3. And where? 2. And when x is 0, what's y? 6. 1, 2, 3, 4. Oh, it's 3 and 2, right? 3 and negative 2. Thank you. So it's there, and it crosses at 6. So it's going to go up like this, and then... No?
You took the negative out.
When you plug in 0 for x, what do you get for y?
No, they were wrong in correcting you.
They were wrong in correcting me.
Because you took the negative out.
Yeah, so it's 3, but it's 3 and negative 2. 3 and negative 2. They are correct. It is 3 and negative 2. What makes this 0? 3. What? It doesn't matter.
What is x plus 3 equals 0?
It's not x plus, but it's x minus 3, Carter. It's x minus 3. Take a look, Carter.
Factor the negative 1 in.
You're not, but that doesn't, bleh, if you factor the negative 1 in, it becomes negative x plus 3.
That all equals 0.
It all equals 0. Okay, so it's 0 and 6, correct? So what does this graph look like? It goes up, and it goes down. And what does y equal 4 look like? It's just a straight line right there. So what are 2 points you have to find out? Where they intersect. You have to find out where they intersect. Do not move. So how do you find out where they intersect? Negative x squared plus x plus 6 is equal to 4. So negative x squared plus x plus 2 equals 0. So negative x squared minus x minus 2 is equal to 0. So negative x, what is it? Plus 1 and x minus 2 equals 0. So x is equal to negative 1 and what? 2. And ready? Here's what you would do. Negative 1 to 2, what's the upper bound? Negative x squared plus x plus 6. Plus x plus 6. And what's the lower bound? 4. There it is. You did that. That's what you did. That's what you did. Look, if you did the integral just from here to here, what does the answer come out to be? I don't remember. I'll put it in here. Your homework will be in the notes.